All right, so this practice problem reads, compare the kinetic energy of a 20,000 kilogram truck moving at 110 kilometers per hour to that of an 80 kilogram astronaut in orbit moving at 27,500 kilometers per hour. All right, so this is practicing our kinetic energy equation. So we want to remind ourselves that the kinetic energy of an object is 1/2 the mass times the speed squared. And if we're going to compare and use our standard units, we want to make sure we're using standard units in all our variables, kilograms for mass and meters per second for speeds. And so our example problem does not have our speeds in meters per second. So let's first make those conversions and then we can compare the kinetic energies using our standard units. So we're first given the speed of the truck, and the speed of that truck is given to us as 110 kilometers per hour. And I need to convert that to meters per second. So I know that there is 1 kilometer. In 1 kilometer is 1,000 meters, so that gets my meters in the numerator of my unit. And I know that in 1 hour, I have 3,600 seconds, and that gets seconds into my denominator. So our truck is 110 kilometers per hour. In meters per second, that truck is going 30.6 meters per second. So we'll do a similar calculation for our astronaut. The speed of the astronaut is, we are told, equal to 27,500 kilometers per hour. And we're going to do the exact same conversion. So we know that there is 1 kilometer, and that gives us 1,000 meters. And for every hour, we have 3,600 seconds. And when we determine the speed of our astronaut in meters per second, we find that they're traveling at 7.64 times 10 to the third meters per second. All right, so now that we have our standard units, we can go ahead and calculate those kinetic energies. So the kinetic energy of the truck is equal to 1/2 the mass of that truck times the speed of that truck squared. And so we have 1/2 the mass, I believe was 20,000 kilograms, yeah, times the speed of 30.6 squared, and we find the kinetic energy of the truck as 2.33 times 10 to the 9th joules. Similarly, if we're going to determine the kinetic energy of the astronaut, we have 1/2 the mass of the astronaut times the speed of the astronaut squared. So we have 1/2, I believe they were 80, yeah, 80 kilograms, times our speed of 7.64 times 10 to the third, quantity squared. And we find that the kinetic energy of the astronaut is 2.33. You know what? I looked at the solution wrong. The kinetic energy, oh shoot. I peeked at my solution and wrote the wrong kinetic energy. The kinetic energy of our truck is not that high. It is 9.36 times 10 to the 6th joules. Okay, so when we actually do that calculation, it's 9.36 times 10 to the 6th joules. And the kinetic energy of our astronaut, that's the 2.33 times 10 to the 9th joules. So the problem then asks you to kind of compare those, which means we need to look at the ratio of our truck to our astronaut. So the kinetic energy of the astronaut relative to the kinetic energy of the truck. So to do that, we take our kinetic energy of the astronaut, 2.33 times 10 to the 9th, divide it by our kinetic energy of the truck, And we get that the kinetic energy of that astronaut is 249 times bigger than the kinetic energy of the truck. All right, so practicing that kinetic energy equation, doing a couple examples, remembering we have to stay in our standard units if we're going to talk about things in the appropriate unit for kinetic energy of joules. All right, good job.